Hello everyone and welcome to my YouTube channel. Today we have day 11 of Kaggle's 30 days of machine learning, and today we don't have any tutorials. As you can see, there is just this, they ask you to check out house prices competition for Kaggle Learn users, so that's specifically for us. So we will go take a look at the competition, and our task is to create a submission. But we will start from the competition page itself. So let's take a look at what things mean and how to join this competition. So I have joined this competition. Otherwise, you will see a join button here. So click on that, then read the rules if you want to, and click on accept. And then you are inside the competition. Now you can read the description. So what's happening in this competition is I think you have to create a model to predict uh, the house prices. So you have 79 different variables of different homes in USA, and the challenge is to predict the final price of each home. So this is the competition description. So all competitions are like this. And then you have evaluation. So you're making some prediction, but it has to be evaluated, right? And the way it's evaluated is using some metric. So Kaggle is using root mean square error, RMSE metric, and you have to submit a file. So that's called a submission. It's a CSV file most of the time, and that should have an ID and a sale price. And this is for the test data. So what is training data? What is test data? We will come to that. Let's take a look at the data page. So you have train.csv, you have test.csv, you have some data description.txt file. It probably gives you a description of the data, and that's what is mentioned here, full description of each column. And you have sample submission. So sample submission is a submission file that is provided to you in correct format so that you know what submission is or what submission file is. And they have also given you some kind of brief description of all the different columns that you are going to be dealing with. So you see, it's a lot of columns, a lot of them, 79 features. Here you can take a look at the data. So you have in training data, you have the ID column, you have some other columns, and probably somewhere you have price or something like that, sale price. Okay, so here you have the ID column, and in the end you have the sale price. And this is your training data. So you have all these columns which are features. Some have missing values. Maybe some have missing values. I don't know. Maybe none of them have missing values. So we have to check that. And this is your test CSV file. So test CSV file is in the same format, except the fact that it doesn't have any sale price column. So that's so you have to build your model on the train.csv and use it to predict on test.csv. And when you look at the sample submission file, so before that, let's see these IDs. You see here 161, 1461, 62, 63, and here you have the same IDs. So instead of submitting the whole test.csv, you just need to submit the correct ID and the price corresponding to that ID that your model has predicted. Great. So what they have done with sample submission is they have created a linear regression model on year and month of sale, lot square footage, and number of bedrooms. And using these 3-4 variables, they created a simple linear regression model, and that's your sample submission.csv. So you can also probably start from creating your simple linear regression model if you want to. Okay, so this is the competition. So there is a discussion forum. If you have some questions, you can ask there. There is a leaderboard where you will see your rank when you submit to the competition. So don't go for this. Somebody has the solution. And yeah, so now we can go to our exercise. So you go to the tutorial, and here, if you click here, you get the exercise. And we just run the first cell as we have been doing. So let's run this and see what we have to do in this competition. Okay, so here it says some of the code has been some of the code you have written so far, start by running it again. So this is something that we have already done. We have been doing for previous, I don't know, few days. We are reading one file in pandas and trying to predict the house price using decision tree regressor and sometimes using random forest regressor. And that's what we have to do today too, but we have to do it for the competition. So now you have to load the data and separate the target. Okay, you loaded the data using pd.readcsv, and they provide you with the input training.csv in this kernel, so you don't have to load it on your own. So it's there for you. Otherwise, you have to do that. And then you create a X. So features is something something. They have chosen some features for you. And what you do is you create X, you choose the features from your home data pandas data frame. If you want, you can print the head of the file, but yeah, don't need that. And then you split your training and validation set. You create your training and validation splits with a given random state. You have done that, and now you are running a random forest model. So let's just run it and see like a simple random forest regressor, what does it give? So it gives me a mean MAE value of mean absolute error of 21,857. Okay, that's fine. Now, the thing is, here, when I'm looking at this competition, I saw an evaluation that they are calculating root mean squared error. So I guess that's a better representation, because if you're doing it for the competition, that's a better representation. But scikit-learn doesn't have root mean squared error; it has mean squared error. Mean squared error, and here I will also import numpy. Import numpy as np. Okay, so now I got mean squared error, I got numpy. So here I can also print validation RMSE, and let's do it using our favorite F strings. Let's take this from here and remove this and put a check. And instead of rf val MAE, it will be rf val RMSE and mean squared error. Okay, and the same thing, this thing can be copied here. So one thing we are missing is the root. So if you have mean squared error, you just take root of that, and numpy dot square root function will do that for you. Okay, now let's run it again. And now it gives me an RMSE of 31,619. So here, if I see the leaderboard, so if I if I am in 31,000, I will be somewhere in thousands, right? So that's also a thing that you should do, is you make your first submission and then you try to improve on it. Okay, so let me just refresh it, because I think this is eating a lot of memory. So 31,000, I don't know, 16,000, 17,000. Wow, you will be somewhere 7. You will be near to 8,000 rank if you submit that model. But anyways, it's for learning, right? So here we create our model again on full data. So there is a problem here. We checked the score on the validation set, and now we are training on full data. So our parameters for the model may not be optimal, but let's do it anyways for the sake of learning. Random forest regressor, since it's a regression problem. And here we fit the model on full data, and our full data is capital X and small y. Random forest regressor. Okay. And we should also specify random state. Random state to 1. Okay, yeah, it's not callable because you have to use dot fit, model dot fit. Okay, so now this part is done. Now we will make our predictions on the test data. So what is our test data? Test data, first we have to read the file using pandas. So we can simply do pd.read csv and then test underscore data underscore path. And here we have created a list of features. We have to use the same features in the same order. So now we will do test underscore data and features. So we don't have targets for test data. Otherwise, you also get zero score, zero RMSE, right? So now we can do full data random forest model dot predict and test underscore x. And this should work. This should give you the test predictions. So here you got all the predictions, and now you can check the solution. Okay, and now you have to generate a submission file. Okay, so what that means? So you have test underscore data. Now in test data you have the ID column, right? And here what they do is they create a new data frame using a dictionary where column name is ID and the other column name is sale price, and this looks same as your sample submission file. Okay, and then you save the file to a CSV file without the index. So this is your test predictions. This is your ID from your test data. So you can also write it like this if you want to. It's the same, and these are the test predictions that you just created here. And then you save the file. Now, once you have saved the file, it should appear here in Kaggle/working. So whatever you save here should appear here. So I can just download this file and it's going to save it on my PC. And now I go back to the competition and here I see the button called submit predictions. So I will go there and click on submit predictions, and here I can just drag and drop the CSV file that I just created. So that's the one of the easiest way of doing it, but I will also show you another way. So I have dragged and dropped the file here, and remember what my RMSE was around 25,000 or something like that, 31,000 on the validation data. So here now I make my submission. So I'm expecting a little bit better than that, but I'm not sure. I'm doing it for the first time. So now it runs your submission, and now you got scored a little bit better than that as assumed. So now you can go to leaderboard and you can jump to your position on the leaderboard. So 7,598, that's my rank. If I click on my submissions, here I can see how much my model scored. Now, another way of making submission would be to just click on code inside the competition, click on new notebook, and this is going to load the data for you. So everything will come here, just like before. And now, since we are done with our assignment for today, I'm just going to copy this thing and paste it here. Okay, and I'm also going to, now I forgot which one was which. Okay, so now I'm also going to copy this part for training the full model. I'm also going to copy the part for making predictions on the test set, and also going to copy the part for making submission. So now I have done all this. I can safely close my exercise window. This is the last exercise for your intro to machine learning. And now here it also says that some features will cause errors because of issues like missing values or non-numeric data types. Here is a complete list of potential columns you might like to use that won't throw errors. So they have been very kind, and they have provided us with some features that we can directly just use and experiment with. So yeah, today this is the last lecture for Intro to ML, and tomorrow we move to a new one called what was it called? Intermediate machine learning. Okay, let's run this. let's run this part first. And one more thing that you should know that you had only 40 submissions or something like that. So if I click on this one, and if I go to submit predictions, it will tell me how many submissions I have left for today. It's because they don't want you to know, like, if you have a lot of submissions, you can guess the scores, right? So they have only 39 submissions. One thing I forgot to tell you is this part here, public and private leaderboard. So public leaderboard here, it says it's only 50% of the test data. The final results will be based on other 50%. So let's say your test data has only 100 samples. So like this test.csv, if it has only 100 samples, they chose 50 of them randomly, and they calculate your score only on those 50 and they show it to you. And when the competition ends, they will calculate the score on the other 50. So the score that you see might not be the final score, but if you did everything correctly, it will be quite close to your final score. So here we have to load the data in a different way. Okay, and now everything should be fine. Let's just run everything to see if everything is working good. So we train the model and on the full data. So let's remove this. Let's just combine these cells and also the cell for saving the submission file. And now we can train on the full data. So what else can we do? So with random forest regressor, you have something called an estimators, which is the number of estimators. So if you have not seen my video on random forest regressor, I would totally recommend you to go there, take a look at that. And also decision trees, then you will understand what an estimators are. So by default, if I look at the help of random forest regressor, let's see what we get. If I look at the help, here I get n estimators. Where is n estimators? Max depth, min feature rate. Okay, yeah, here it was. Sorry, 100. So let's see and try to see if we change it to 200, what happens. So my previous error that I got was 31619, and now we see with 200, I'm getting 31567. So it's a little bit of improvement. If I do 700 estimators, so if you have a lot of estimators, it's going to be a little bit slow, and you might also end up overfitting on the validation set. So now I have 700 estimators. Okay, let's just run this, and now I don't have to change anything here in the test on the test part, except this thing. So here I can just do n underscore estimators equal to 700, and I can click on save version, and it will save the version for me. So now we wait for some time, it's saving. So all you have done now is taken the previous code and changed the value of n estimators to 700 instead of 100. Now we go back and see how we perform on the leaderboard. So we do see that we have some improvement on the RMSE. So is it going to reflect in our score? Let's see. So after a few seconds or a few minutes, you will see that this is successful. So I can open it in viewer, and here I can see my notebook. So it ran on Kaggle environment. Here is my notebook. Just ignore the last cell. That's for us for later use. And here is the submission.csv file in the output section. And now I can just click on submit. Since it's associated with the house prize competition for Kaggle Learn users competition, it's going to submit to that competition automatically. And here it will ask you if you want to write something about this or whatever. So you could have written n estimators equal to 700, but let's leave it. Okay, so now we see we improved our score by 1000. So if we improved our score by 1000, how much rank did we improve? Oh, 3000. Yeah. So we improved our rank by 3000. So is there anything else that we can improve? They have given us a list of features. Not all features are always good, but what we can do is we can try these features and see if they make any difference to our score. So let's convert this to a list of features. So I have quickly added comma at the end of everything, and I will close this here and open this here. Let's copy this to our features. So these are our old features. Let's keep it in a comment if we need it later. So features equal to, now these are our new features. Wow, so many features, right? Okay, so yeah, if you want, you can format it in a good way. I like to do that. So let's see. Okay, so now it's more readable. So these are the features that we have, and I don't know if, okay, yeah, we do have some of the old features here. Maybe we have all the old features here. So what I'm going to do now is I'm just going to run it with 700 estimators for obviously training and for test. This should be the same, and I'm going to run it on all the features that we got, and let's see what happens. So my notebook has failed. I got a message failed, and now we will look at why it failed. So let's see what the error was. Okay, it's giving some value error. Input contains non-infinity or a value too large for d-type float. Okay, so they gave us the feature, but and they also told you that these features will work. But they didn't tell you that in the test set you can have missing values in these features. Sneaky. So what we are going to do is we are going to do something very simple. We are going to replace all missing values by, now this is tricky again, by 0, let's say, for now, because we will learn about how to handle missing values in more details later, but right now let's just fill all the missing values. Test data go to test underscore data dot fill na, that you can use to fill all missing values by -1, let's say, and then let's just run it, look in the kernel first, make sure everything is working, and we can also see if our validation RMSE has improved or decreased. So my validation RMSE has seemed to be improved by quite a lot. Now it's around 25,000. So now I run it on all the features and the test data, and let's see. So this is the model is training again on full data set, and it takes few seconds, maybe, or several seconds. And now it's done. And one more thing that I can show you here, you also do output dot head and look at how your submission file, your final submission file looks like. The first few rows, just sanity check. So we save the version again. Now it's queued and it will run. It seems to be done. We will open the viewer and we will click on the output and go to submit. Let's check, because we had some improvement locally, so now we can submit, and hopefully it gives us a better rank than before. Okay, so it does give you a better rank than before. So your score has improved. If I go to my submissions, I can see our first submission was 21,000, then I had 20,000, now I have 16,000, and RMSE should be low. It's like error, lower the better. And if I go to the leaderboard now, I have my rank under 1000. Now maybe we can try something else. This time we had tried an estimator 700. We tried some of the features here, but we can also try all of the features if we want, and then see what we get. But instead of doing that, we will do something else. We will just write try another model called gradient boosting and see how that performs. So like here I have gradient boosting regressor. So this is my RF model, and now I will say GBM model. So don't worry about it, you will read about it. So, but it's nice to see uh, what difference can it make or cannot make. And here also you have n estimators. This is like it's based on decision trees, just like random forest. And here I can just do GBM model, GBM val predictions, and we can print the same things. Or maybe I just remove the validation MAE. I don't need it. And here I have GBM model. So this will be GBM. Copy this, and so we didn't have to make many changes. We are still using the same set of features. We have not done any kind of exploration of data that we should do, and that's I'm leaving that task up to you. And you can also choose more features if you want. And now let's try here what happens. So X is not defined. So where did we go? Somehow X got deleted. X equal to home data features. Okay, and let's see what is the RMSE score from both these models. So you can see the validation RMSE of GBM model is 22,000. For random forest, it's 25,000. So we do have some improvement. And then one more thing that we can quickly try is just using one of these models. So let me just remove all of this. And yeah, we do need this. And our final predictions will be a combination of these two, rf underscore val underscore predictions and plus gbm underscore val underscore predictions. So it's, don't worry about it. I'm just showing you to take average of two different model predictions, and we are just checking if it changes the score. So yeah, okay, one bracket is missing, and now we run it again and we see what happens. Okay, so now I get 21523, which is a little bit better than both the models. So what I'm going to do is I'm just going to take this model, take this whole thing from here, and I'm going to paste it here. So RF model, and here I have RF model and RF model, and this is your first set of predictions, and your second set of predictions will be the GBM model. So you also need to fit it on full dataset dot fit x comma y, and here test spreads to GBM model, and your final test underscore spreads will be test underscore spreads 1 plus test underscore spreads 2 divided by 2. So this is one way of combining output of two models. So we fit RF, we fit GBM, and I hope this should work. So we can just save the version. And then we wait. Okay, so this is done now, and yeah, 21,500, and we will just submit this and see how it scores. And with this, we will also end today's video. So if you go to your, let's open this page, and if you go to the machine learning tutorial from today, click on back to course home. There you have done everything in the intro section, and you can then view your certificate. So here I got 15334, which has been an improvement on the previous scores. So we have also improved our score quite a lot just by changing few things in the model without even touching the features. And that's what I wanted to show you today. Go dig into the data, look at the features, build some more new features, look at how to handle categorical variables, and see you in the next day. And if you like the video, do like, do comment, do subscribe, and tell your friends about it. See you next time. Goodbye.